Hello and welcome to this tutorial. My name is Frederik Steinmetz for BlenderDiplom.com, and today I'd like to talk about the array modifier. The array modifier creates copies of your object, and that's about it. Still, it has a bunch of settings, so let's talk about them. You can see immediately when I add this, the cube gets twice as long in, and that is because the count is set to 2. So you can see the count is not the amount of copies that we're creating, the count is the amount of objects we're ending up with. So right now the cube, if I set the count to 3, we add exactly 1 cube, as you can see here. So by default the relative offset is the only option that's checked, and if I turn this off, the array modifier looks like it's disabled, but it's not. It's just all the cubes are stacked inside each other. So if I turn back on the relative offset, let's have a look at the options. You can see all the objects fit neatly and there is no gap in between them. But if I go into edit mode and rotate this, you can see that the distance between the cubes changes. So why is that? The relative offset goes by what's called a bounding box. And you might think, bounding box, the cube is a box, so why does it matter if I rotate it? That is because the bounding box is oriented along axes. And since the cube is not rotated, the axes are the world axes, or at least are the same as the world axes. If I go to bounds, you can see there's no difference because the cube is aligned with the axes. If I rotate this, you can see the bounds grow. And that is because the bounding box is the smallest box Blender can fit around the cube while following the axes. So that's exactly what happens. If I go back into this view and go back to the array modifier, you can see this is where the bounds end. So this is where the cubes go. They don't intersect at all in X. This vertex has the exact same X coordinate as this vertex. So if I scale this down, you can see the cubes are following. And that's because it's a relative offset, relative to the size of the bounding box, not to the size of the object. And since I destroyed the transforms of this cube, let's just add a new one. Here we have the relative offset. I'm going to move this here so we have like a ruler and switch this to constant offset. And now this looks like it's half as wide, and it actually is. The constant offset is also set to 100, but you can see here this is called a factor and it doesn't have a unit behind it, and this is called a distance with a unit. So 1 meter means, compared to the relative offset, it's half as much because the original cube has 2 meters in width. So it's 2 meters wide, and 4 times 2 times 1 is 8, so this is 8 meters wide. And if I turn this to constant, you can see it's now just 5 meters wide, which is the original cube plus 4 times 1 meters offset. So if I scale this down as 0.5 by half, you can see now there's no difference between the relative and the constant offset, simply because the cube has a dimension of 1 in X. Now I can of course increase this and play with the gaps, but I think you get the point. The same goes with the options for Y and Z. It's fairly straightforward, but it's also fairly boring. So let's have a look at the more interesting option, which is the object offset. And for the object offset, of course, we need an object. So let's just create one, an empty, and let's again go back to the array modifier, pick the empty by using the eyedropper. And now nothing happens, and let's increase the count, and now we can move the empty. Now moving this in X, and let's just press 1, so once again we have no difference between the constant offset and the object offset, because the difference between their transforms is exactly this 1 here. So all these transforms get copied over to the next cube that is created by the array modifier. And if this is too abstract, let me just scale down this empty and see what happens. And now you can see not only the offset is transferred to the next cube, but also the scale. And this is where it becomes really cool. if I move this in, you can see I can create some sort of tower, but the real fun begins when I rotate this. Now we have a tentacle. So basically you can animate this really fast. And now I could just keyframe the transforms of the empty in order to make this pretty interesting. While this might be a very cool animation, let's have a look at what I'm mostly using the offset for. And for that, I'm going to go into top view and I'm going to create a circle. Mesh circle, we need a number that can divide 360 by a whole number. Well, this would be 10, of course. So now we have 10 degrees in between two of these vertices, and let's just delete most of them. Like so. Let's just keep these. That should be easy enough to follow. I'm not going to go into the details of what I'm doing here too much. All you need to know is I'm creating a circular segment. So I'm going to again add an array modifier. Don't care about the relative offset, and I'll choose the empty. And now the scale of the circle is less than the scale of the empty, so we get these radial waves. But that's not what I want, so I'm going to press Alt-S to reset the scale of the empty. And now we have 360 divided by 36 is 10 times 3 is 30. So if I rotate this R30, you can see we get the full circle, which is really nice. Why, you ask? Because now I can model one segment of my circle and it will be transferred to all the rest of the objects. So I can do cogwheels, stars, all sorts of cool things. Let's get to the next option, which is merge. For this, I'm going to make this 3D. By 3D, I mean I give it a depth. Right now it's flat. E and Z, and pull this down. All right. Now, I'm going to use a subsurf modifier. I just press Ctrl 2, which adds a subdivision surface modifier with level 2. And I don't need to see it, so I'm closing it. So this looks kind of cool too, but this is not what I want if I am going with a cogwheel. So as you can see, this creates individual copies of the original object and just arranges them in a circle, which is something you can't see if I don't alter the geometry afterwards. Once I click merge, the vertices will be merged, and now the copy of this vertex occupies the same space as this vertex, so the distance between the copy of this one and this original vertex is 0. The distance is larger than 0, so they get merged. You can much more easily see this if I shade it smooth, but you can also see a huge issue. Let me fix this real quick, because we'll get back to that in a second. Now that's fixed. Okay, now you can see there is no issue left. Let's just quickly compare this. If I don't merge it, you can see all these lines. If I merge this, these lines will be gone. Let's decrease the count until it's exactly closed. And you can see there's one last line remaining. And that is because the first and last copy are not merged. And you can of course just fix this by clicking first and last. You should probably not go overboard with this merge option because it can do strange things. But by default, this is a really handy option. And of course, as long as you don't create something circular where the first and last object meet, you don't need to turn on this option. Let's create the cube again, add a modifier, array modifier again, increase the count, add the subsurf modifier, shade it smooth, and click on merge because I want to address this issue. And we have these strange black lines, and they are of course a normal issue. And by normal I don't mean usual, even though it's a common occurrence. The normals in Blender are what's pointing away from individual faces. If you want to know a lot more about normals, go ahead and check out our book. But for now, let's continue. The problem at this point is that if we go into wireframe view, we can see it. There are faces intersecting our sausage which are not supposed to be there. And to make matters worse, they even duplicate, because this face will receive a copy of this face right on top of it. So if I delete this face, you might expect the problem to go away, but it's not. It's just becoming white instead of black. So what we have to do in order to get rid of these completely, I have to delete both faces. So that fixed that. But now we have an open cylinder. What if I want to close this? Because it would be quite a shame to have an array and then not being able to close it. And this is exactly what the cap option is for. I'm going to skip over the UVs for now because I don't think they fit at this point. And we're going to have a look at the caps. And I have an end cap and a start cap. And let me just switch this to my prepared open cube. Let's have a look. This is the end cap, and you can see it's larger than the cube. And the secret for this to work is that the diameter of this opening is the exact same diameter of this opening. And the same goes for the start cap. You can see this is exactly 1 meter wide, and if that's not what you're doing, it will look odd. Of course, there are ways to fix it, just increase the merge distance, but for now I just left it at 1 meter in diameter. So if I choose the cap start, this fits exactly, and if I choose the cap end, this also fits neatly. If I choose the merge option, the seams will be fixed, which is quite nice, and you can see this geometry gets copied and put in front of here. So if I change the geometry of this and go back out of edit mode, you can see this messes up this structure. So I'll undo this. I can also hide these and it still works. And of course, to get rid of this seam, we need to merge it. And in case there's a slight difference between the diameter of this and your object, you can always fix that using the merge. If I increase this, you can see at some point it snaps shut, but of course it's best practice to have the difference between this opening and this opening as small as possible. So those were the cap start and end options. Let's have a look at the two that are left. One is the fixed count, which is the fit type. We can choose fit length and fit curve. Let's choose fit length first because it's the easiest. A length of 0 creates, of course, 0 copies and just leaves us with the original cube. If I turn off the caps for a second, you can see in the dimensions it's 8 meters because it's rounding up. So once we hit the threshold of 10, it jumps up to 11 because this is the length of the copies. And of course it can't go smoothly because it only elongates the tube by creating another copy, which means there is no linear interpolation, like as if I was using the scale, but we're creating additional copies. So that's fairly straightforward. And the interesting thing is fit curve. So for fit curve, of course, we need a curve. I have prepared one here, and that's our curve. I can again use the eyedropper to choose the curve. And now if I animate the length of the curve, you can see that the number of copy rises and falls. So this is not very impressive because right now we could do the same thing with a length. But if we actually add another modifier, curve modifier, and let's move it up and pick the object. Now you can see in the array, the created array is following the curve, and now you can see it's really handy that the array modifier fits the curve exactly. Still, it's not a smooth animation, but it's much better to do it this way than to actually use the curve modifier with a fixed count, and then whenever you change something or even animate it, you need to go back in there. And adjust the other settings, which would be quite cumbersome. That leaves us with one last option, which is the UV option. Let's add the array modifier and let's go to the UV option. So I can increase the count, and I can also go to material preview because I already assigned this texture with an arrow to it. I chose it so we can easily see how it's offset. So the U corresponds to the X of each face, and the V correlates to the Y of each face. So if I offset this in U, you can see it looks like they're moving closer together. That just means that the X coordinates of all the copies of the texture, I could say, I guess, are moving closer together. And you can see this does not go above 1, which is quite smart because the UVs are relative and they wrap. So if you go to 1.5, it would be exactly the same as using 0.5. You can do the same thing as in V, and you can see if I offset this in V, the textures, it has a very similar effect to offsetting the planes in Y, and then countering this using the V offset. So basically this is a great option to get some more variety into your copies because they can look quite generic, and you can counter this by getting some more variations. That about wraps it up. We've gone through all the options the array modifier has to offer. Thank you for watching, and also please do try this at home. If you think you've learned something from this video, please go ahead and hit that like button. If you want to see more videos of this kind, please go ahead and subscribe to our channel. And if you're interested in cycles whatsoever, please consider buying our book. It contains all the information about every node, as well as a lot of tips about performance, denoising, and so on.